Welcome back. The next law that we're going to look at is Avogadro's law. Now, the name sounds familiar to most of you, and we won't technically use that number in this context. It's just the person that designed both of those. All right. Now, as with the previous laws, Avogadro's law is, I'm not really sure why. I think maybe it's a shortcut that people come up with it to explain it. But technically, you can actually use the ideal gas law to actually explain Avogadro's law. Let me say what that means. So in this case, Avogadro's law, pressure and temperature are kept constant. Okay, and R is always constant. So volume is directly proportional to N. We've already looked at that. You know, pressure of particles in a container is directly proportional to how many there is, right? So volume and number of moles are directly proportional. That is, you increase number of moles, you increase volume. You decrease number of moles, you decrease volume. Okay, so here's a problem. Now I'm going to solve this problem two ways, and you'll be so surprised. Wow, okay. And then I'll let you pick which one you want to choose. But typically when you're dealing with grams and moles, you can use the Avogadro's law itself, or you can actually use the ideal gas law. Both would give you the exact same result. So I'm going to work out both of you and then leave you with a couple of practice problems. Right? The question says 50 grams of nitrogen gas corresponds to what volume? This should have been corresponds to what volume at STP, right? So ultimately we need V2, right? That means first we got to find the N1, which is nowhere to be found here. Assuming this will somehow go to get N2. So what's V1? Well, there's so many things that we don't know, and then we have to find V2. But keep in mind, at STP, 1 mole of any gas corresponds to 22.4 liters. So technically what you could do is treat your 1 mole as N1 and 22.4 liter as V1. Now, how do I know this is there? Well, because the question clearly says STP, right? And STP is 1 mole of any gas. Well, STP itself is 0 degrees, which is 273 Kelvin, and 1 atm. That's the reaction condition, but then that also enforces the fact that 1 mole of any gas at STP. So right away we know N1, we know V1. We don't know N2, but we can get N2. How do we do that? Well, 50 grams of nitrogen is 28 grams. N2 is 28 grams over 1 mole, right? So 28 grams over 1 mole is 50 over 28 is 1.79 moles. Okay, now we know N2. We know N1, we know V1, we know N2, we can find V2, which is V1 is 22.4 liter over N1 is 1 equals V2 is what we need to find, and N2 is 1.79 moles. We just basically multiply that. So V2 would be 22.4 times 1.79 is 40 liters, right? This is one way to do this. Say for some reason your brain just doesn't want to get out of the ideal gas law. Well, you can still do that with Avogadro's law. Let's do the same problem. This is option 1. Okay. Option 2 would be PV equals nRT, right? Well, STP suggests pressure is 1 atm, so P is 1 atm. V is what we need to find. N, we get that from the mass provided, which we already did, 1.79 moles. R is gas constant. We use the lower value because we're dealing with volume. And T is 273 Kelvin because it's STP. So basically we can use this condition right here and then the ideal gas law to solve for V, which will give you the exact same answer. So 1.79 times 0.0821 times 273, which is 40 liters. So this is I have not seen this problem explained this way on the internet, but technically Avogadro's law is one place where you can go back between Avogadro's law and the ideal gas law would give you the same answer. Okay, I'll let you pick which one you want to pick, but traditionally when you see moles and you're given grams and you're asked to find volume, you can use the Avogadro's law, right? So here's the two problems I want you to practice. The bottom one is straight plug-in chug, okay? You do not have to convert it to liters. As I said, the only time you convert in two variable is if it's temperature, and then in an ideal gas law, you convert everything to the appropriate units, right? So in this case, you do not have to convert anything on the bottom problem. And on the top problem is very similar to the problem I worked out earlier, except this time I'm asking for moles. So go ahead and try that. Again, you may want to watch the video, this particular video, more than once because it sounds very easy when you watch it, but then somehow you may think it's difficult. But then when you watch it one more time, you may have missed something I said, and that might partly what would contribute to the problem. So just watch it one more time and you'll be good to go. So go ahead and practice this and solve these problems as part of your My Thoughts, right? So stay tuned.